In this lecture, we're going to look at cost theory. We're going to look at an individual firm and determine when and if it has economies or diseconomies of scale or size. We will also look at what is meant by rent. In some cases, rent can be collected by government without affecting the efficiency of the firm, but in other cases, the rent that governments collect will result in a firm reducing its output or leaving the industry. First, we provide some definitions. Total revenue is defined as price times quantity. Total costs are denoted TC. Variable costs, total variable costs with TVC. Fixed costs, they don't change. Average variable costs, average total costs, and marginal costs. Here we provide the cost functions and determine what is meant by producer surplus. You'll notice here that I have on the vertical axis dollars per unit quantity and quantity on this axis. We have the average total cost curve and the average variable cost curve. The average variable cost curve simply takes total cost, subtracts from the total cost the fixed cost, and then divides the number so that as Q increases, so basically what we have is total variable cost divided by Q gives you the average variable cost as Q increases. If we look at fixed cost, you can imagine fixed cost. Suppose that the fixed cost is $100 and you produce 1 unit. Then your fixed cost is $100. Your average fixed cost, pardon me. If we produce 10 units and the fixed cost is 100, then the average fixed cost is only $10. If we produce 100 units, then it's only $1. So if we add to the average variable cost, the average fixed cost, we get this average total cost value here, this upward, first downward sloping, then upward sloping curve. If we look at the marginal cost, which is the difference between the average variable cost for producing Q2 units compared to Q1 unit, then what we do is we find that the marginal cost will be falling and eventually it'll rise. And the mathematical properties of this are such that the marginal cost intersects the minimum point on the average variable cost curve at this point QS, and it intersects the average total cost curve from the bottom at the minimum point of the average total cost curve. Now, if we are at this minimum point and the price should happen below P of S, then the firm will shut down, because at that point the firm, suppose the price is here where this marker is, the firm will then end up losing money. It won't even be able to cover its average variable cost or its variable cost. So as long as the price is above this PS or price of shutdown, the firm will continue to produce. At the point P0, if the price is P0, at that point Q0 is produced and it breaks even. In other words, it covers both the variable cost and the fixed cost. Any price above that, let's say P1, earns the firm some kind of a profit. Now notice that the quantity that is produced is always given by the price equal to the marginal cost. All right, and the marginal cost could be considered the supply function, and we'll get into that a little bit more later. But the point is, if the price is P1, then this whole area above the marginal cost curve, above the supply curve, down to this cost curve here, this cost here, becomes a pure profit. At P0, however, there is no pure profit, but there is built into these cost functions normal profit. So again, let me point out that as long as price is greater than the shutdown price, the firm earns returns to the fixed factors of production. So now we define the pure profit as pi equal to total revenue minus total cost. If we were to take the first derivative of this, we would get marginal revenue equal to marginal cost if we set that first derivative equal to 0. Now we define quasi-rent as the difference between the total revenue and the total variable cost. And that is equal to the pure profit plus the total fixed cost. And we also refer to that as producer surplus. And as I mentioned, it's the area above the supply or marginal cost curve and below the price determined in the market. Now turning to a complete picture of this, we get that the quasi-rent at P1, that was that price that we had on that first slide, is equal to the total revenue, which is P1 multiplied by Q1, so this is your total revenue, minus the total variable cost. The total variable cost at that is given by KB, this price here, or this cost rather. So this KB Q1 0 is equal to the cost of production, the total cost of production. All right, so the profit then is this area P1AB, so P1ABK. And the total fixed cost is equal to this area KBDC. That's our total fixed cost. And then CD Q1 0 is our total variable cost. Note that the producer surplus is given as the area above the marginal cost curve. It's equal to this area here. So P1 down to R and then E and up here to A. That area is equal to that same area P1 ADC, P1 ADC, and that's equal to that area P1 AER, all right, which is also known as producer surplus. For our purposes, marginal cost above the shutdown point, remember here's your shutdown point, QS is your shutdown, you won't produce anything below QS. That constitutes the supply function. Summing over all firm supply functions gives the market supply function. Now let's consider government collection of resource rents. The first thing we have to do is define what is meant by a rent. We've already talked about quasi-rent as producer surplus, but here we're talking about two different kinds of rent. One is called differential rent, or sometimes it's called Ricardian rent, due to the insight that David Ricardo had in 1817. And the other is scarcity rent, that results because land or some natural resource is scarce. Scarcity rent can sometimes be created by humans simply by restricting access of one form or another. And we'll discuss that in the cases of the marketing boards and US-Canada softwood lumber trade. Let's first consider Ricardian rent, which in this case, Ricardian rent is associated with land quality, which is where Ricardo first came up with it. So here we have three different farms, and these farms have different cost structures given by the average cost curve here. This is your variable cost curve and your marginal cost. So we have A, B, and C, and you'll notice that the costs to farm B are higher. The whole cost structure is higher than it is with the case of A, and likewise with C. And what could be accounting for this difference in cost could be simply different rainfall, precipitation amounts. One piece of land is located in an area which gets a bit more rainfall. Another reason in agriculture occurs when you have fields that somehow generate rocks. You get these rocks coming up all the time, so that the farmer has to go in and either by hand take out the big boulders before bringing his machinery in, otherwise it would damage his machinery, or he uses what's called a rock picker, which is an automatic rock picker that picks up rocks. But in either case, it ends up giving higher costs, which could explain why this firm has a higher cost than the others. This P is our average revenue, but it's also our marginal revenue. The price is the same to all farmers who are growing this particular crop. So the three fields differ, and if we think of this price being the same to each farmer, then farmer A collects this pure profit, if you like, which is really a rent because his costs happen to be lower than those of a neighboring or other farm. Same thing with B, collects some rent, and C is collecting no rent but earning a normal profit. The point is that the government could take away these rents, these shaded areas, without changing the amount that these farms would produce. And that's, they would still get normal profit. Johann van Thuenen critiqued Ricardo's idea of rent because where Ricardo was working in Britain, he observed quite a bit of difference between one farm and another in terms of their ability to produce crops. Van Thuenen in 1840 made the observation that land in Germany was everywhere of approximately the same quality, and as a result he observed these circular patterns of land use around cities, as we'll see in the next slide. So here we have the observed land use patterns about cities in the early 1800s, and you'll notice that the city is located here in the middle, and around it you have dairy and fresh vegetables and fruits being produced. Then you have forestry is the next band of production, and then grains are produced outside the forestry area, and then finally hunting occurs out in the farther reaches away from the city. And this pretty well describes much of Central Europe. The reason you have dairy and fresh vegetables and fruits is because they tend to spoil quite rapidly, so they have to be close to the city. It takes a bit of work to transport them. You can't transport them for more than a few hours or else they could spoil. Forestry is in this area for the simple reason that people needed wood for heating purposes and cooking, and then the grains are further out. So how do we explain the rent distance relationship that van Thuenen observed? Well, we start by creating these rent distance functions, and that helps us also to define what is called an extensive margin. So what happens is we can look at the rent. Remember that shaded area in the Ricardian diagram? Well, that's what's occurring. This is the amount of rent that somebody who had a dairy farm right next to the city would earn, and dairy farms further away would have to incur transportation costs to get their product to market. But at some point, some distance from the market, you end up having to change land use. You can no longer produce dairy because the spoilage as you try to bring your product to the market is just simply too great, and you don't earn any more rent. Here you're earning this, what we'll call the normal profit again, and if you drop below that, so if you're a further distance than this distance from the market, then the spoilage and transportation costs don't make it worthwhile anymore to produce dairy products, for example. So the rent distance function can explain that land use pattern around the city. So here we introduce a second rent distance function where if you're right at the city, you have lower rent than if you were to do and produce dairy products and fresh fruits and vegetables. So as a result, you would produce something different, but you wouldn't. You'd produce item A instead of B because at the market, item A would earn you more rent, more profit if you like. But there comes a point here where it switches. Now beyond this point, beyond this vertical line here, if you're further out from the market, you would turn around and produce use B. You'd produce commodity B. So in this case, you'd go into forestry. The extensive margin, where you go to 0, where you have no profit, remains this point. But here we have what's called an intensive margin, where you'd switch from use A to use B. Putting it all together, we can see that as you introduce more uses, for example, use A, use B, use C, dairy, forestry, grains, then you would switch at point 1 from dairy, use A, to use B, and at point 2, you'd switch from forestry, use B, to use C, which was grains. Points 1 and 2 refer to the intensive margins, and these points here refer to the extensive margin. Now notice that if we plot kilometers in this direction and kilometers in this direction, we end up getting these circular kind of patterns around where the city is located here at the origin point 0. And we can finish our diagram here by introducing use C and use D, so we get these intensive margins at points 1, 2, 3, and then we get these circular kinds of patterns around the city here. And notice that out here is your extensive margin. So anything outside the city in this direction, if there's no other city that's influencing land use in this area, this would just be left as in a natural state. We talked about differential rent when it came to both Ricardo and von Thuenen. In fact, von Thuenen's location model with concentric circles around a city has been employed in geography to explain land uses on a much larger scale. For example, if we were to show a railway or a highway line going through the city, the concentric circles would then change by following along the transportation corridor, so that you'd no longer have a concentric circle, but something that looked like a stretched out circle or an ellipse. Anyway, that's differential rent. You'll notice that it looks very much like producer surplus or quasi-rent, but it's not. And the reason is this marginal cost curve, or we probably should call it a supply curve. Because in this case, the marginal cost or supply curve allows all factors of production, all human factors of production, to vary. So in the other slides that we had, there was always some kind of a fixed factor of production that humans had created. But in this case, we have no human created factors that are fixed. They're all variable. The only thing that is fixed is the natural resource and its availability. So in the case of the farming, where quality of land determined the natural resource, the differential rent. In the case of von Thuenen, it was location, and location theory became big as a result. But here we're talking about something different, and that's scarcity rent. The scarcity rent occurs because some factor of production is limited. For example, people think that oil and gas are limited and that the price is higher than the cost of production, in which case you get a scarcity rent. The same thing might be true in forestry. We have scarcity rents. The two together, the scarcity rent and the differential rent, constitute a natural resource rent. So let's look at these types of rent. So resource rents are the sum of the scarcity and differential rents. The scarcity rent is the difference between the marginal revenue and marginal production cost that can only come about as a result of natural or policy-induced scarcity of a resource. And by policy-induced, I mean something like what we've recently seen in the climate change policies, that we stop producing oil. For example, the US now has restrictions on oil taken out of Alaska, for example. Ricardian or differential rent is the excess of the market value of non-marginal units of an in situ resource, that means a resource in place, over current scarcity rent. What is interesting about these resource rents is that taxation of rents does not affect behavior of firms or resource suppliers, assuming the rent capture mechanism itself does not distort the behavior. So in other words, governments can tax those rents without distorting the behavior of the firm or owner of the resource. Then we have the quasi-rents, which are our producer surplus. These are returns that accrue to resources supplied out of human and human-created capital, and which are not attributable to natural capital. Only for human factors of production do they equal the difference between the total revenue and total variable cost. Notice that's important. Only for human factors of production. Now, if you tax these rents, you're going to affect long-term efficient behavior of firms and resource suppliers. For example, if the government of British Columbia were to impose taxes on forest companies that exceeded the taxation on resource rents, but rather began to chew away at their quasi-rents, then what they would do is stop investing in the industry. So again, why is this important? Well, consider forest rents. They're of two types. First, location. The extensive margin is the boundary between the working forest and nature. In Sweden, the working forest constitutes about 95% of all the forest available in that country. In BC, the working forest is about 60%, or actually less than 60%. Why is that? Because of government policies. Number one, to basically put some land into a conservation reserve, but also because some forests are located so far away from any transportation corridors or are so high up in the mountains that you just can't get at them. So that's your location. On site, it does not pay to remove all logs from a site. Timber companies will only remove logs as long as they will earn at least as much as it costs to remove the log. So what happens when we do that? So here we look at the rent due to location, the extensive margin. So what we do is we line up all of the stands that we have that might be considered for the harvesting, and we say that we have 0, n. So this distance here represents all of the stands that we have in all of the forests that are available for harvesting in British Columbia. And the stands n are worth a lot less, have a lot less value than those at k. At k, the rent has gone to 0. All right, so there's no excess rent. So this AB represents the rent function. Our working forest then is given by this distance from OK. These are the number of stands that could possibly be harvested because they give a normal profit or a normal profit plus some additional rent. So these stands will earn a positive rent, these will earn a negative rent, and therefore they're not considered harvestable, and thus K is our extensive margin. If we look at a particular site, however, we can find the intensive margin. So again, we have the rent up here. This time what we're doing on a particular site, a forest site where we're going to harvest, we have logs arranged in decreasing size and value. So this is the marginal cost of harvesting the logs. We could easily make that marginal cost upward sloping if you like. It doesn't change the argument. This is the value of the marginal product. If you recall, value of the marginal product equals the output price multiplied by the marginal product of the logs. So in other words, the marginal product of getting another log. So in a competitive industry where the marginal cost of harvesting is given by this, and it can vary from one site to the next, but then we're into the extensive margin, where the marginal cost equals the value of the marginal product at point M, that constitutes our intensive margin. Now the government levies stumpage fees that result in a shift downward of that value of marginal product curve. In other words, it increases the cost, reduces the value. You can think of it as reducing the overall price that one gets for a particular log on a per cubic meter. So what happens is when they do that, we go from M to M prime. So we reduce the amount of logs that are harvested, and we leave on the ground logs that are smaller in size than those of M prime. Remember, we've got logs decreasing in size and value as we move from left to right. So when we do that, of course, this value of marginal product curve shifts down to VMP prime. But the government doesn't like this happening, so it forces the companies to harvest back to M, all right, through a utilization standard. A utilization standard forces the companies to harvest smaller logs than are justified. In other words, the amount they get for the log that they harvest in this between M prime and M is going to be less than the cost of harvesting. So they're going to lose this triangle, basically. In other words, the utilization standard no longer collects the rent, but it collects the quasi-rent, the producer surplus, and it makes companies less apt to invest in these properties.